There is no one single solution that will meet everything.
Hello, hello. I have my friend Sandeep Kulkarni, the founder of Cool Earth Solutions. But more than that, a wearer of many hats.
A large scale switch to a paper bottle will take some time and may not happen really soon.
But you and I both know paper is no saint either, right?
Recycling is by far the most practical end of life for packaging because you're maximizing the value of the fiber.
You have this plethora of experience leading Starbucks Cup Challenge.
There's been a lot of evolution, and there continues to be an evolution in applying barrier to molded fiber.
Is that reality, or it's more of rumor mongering that happens?
The number of composters that accept food packaging is even smaller than the overall number of industrial composters.
India actually mandated that we're going to go to 40% recycled content in food packaging.
But at that point, you kind of have to ask the question, is it still paper or is it mostly plastic now? So
from a packaging standpoint, the dharma is protect what is inside.
How do we make this a better world for the coming generations?
What gives you true hope that this is going to really change some part of the world?
I'm still very hopeful about the future for sustainable packaging.
We can crib all we want, but ultimately the key is, what are we going to do about it? Hello. Welcome to the Good Garbage Podcast. My name is Ved Krishna. My primary reason for existence has been to find ways to leave our wonderful planet cleaner. We will be speaking with material innovators, creators, and propagators to learn from them how we can build for scale and towards a regenerative future. Their stories will help us answer the big question, what is good garbage? Hello. I have my friend Sandeep Kulkarni, the founder of Cool Earth Solutions. But more than that, a wearer of many hats. So Sandeep, I want to immediately jump into this. Which hat has been your favorite so far in all your years of so much amazing work?
I think that makes it a little hard to pick with because I enjoy all of them in a sense. Of course, the Cool Earth Solutions is sort of my baby. It's something that I launched about 8 years ago, and I've been really passionate about growing it and making an impact on for companies and their sustainable packaging. So I think that probably is the one I would pick as the one that I feel most proud of and the most that has had the most impact, I think, from my personal perspective.
This gets you in a lot of trouble, my friend, because I thought you were going to say your daughter. Or being the father. Since I know your family.
Yeah. No,
Yeah,
yeah,
she is going to listen to this podcast, you know that, right? And
yes.
you just downgraded her to number 3 or something.
I was thinking
Okay, but let's
level, yeah.
let's park that banter. I want to actually not go sequentially. Normally, it's my my kind of structured brain tends to go, okay, let's go sequentially. But
Mhm.
with you knowing you for so many years, I want to
Yeah,
jump into PepsiCo because that's been a long inning for you. You came
correct.
from a very different background, and of course, you made a huge difference there, and it's a huge company to work at. I want to really dig into that and hear from you how materials work, how big companies work, and what was your overall experience in kind of transforming such a behemoth. So, what was that like?
Yeah, so it was an interesting journey in PepsiCo for sure. I mean, the way I was hired was almost by accident. We all know a consultant in the paper industry named Chuck Glass, who has been around for a while, and he was consulting with Pepsi on some paper projects, and he was not ready to commit full time or give anything more in terms of time commitment. So he referred my name to the manager there at PepsiCo, and that's kind of how it worked out. They reached out to me, and like you said, it was my first foray into the CPG industry, especially something as large as Pepsi. And I really didn't know what I was kind of getting into when I jumped in and joined. Luckily, I think the one thing that was really positive at the time was PepsiCo was really committed to doing some really advanced research. In a sense, they had formed a new group called PepsiCo Advanced Research, which pulled in people from beverage packaging, the food packaging, and also other areas within PepsiCo, not just packaging, but like food processing and those type of things. So they formed this kind of a pretty cohesive group across different locations within PepsiCo. And when I joined in, I think there was a lot of support for doing some really cutting edge research and projects that would make a difference to the company. So it was not just something that you could launch in 6 months or 1 year, but even 5 years out. So there were technologies that we were looking at. Just to give an example, the first project I worked on was a paper bottle project, which is now kind of coming back, and there's a lot of interest in that. But back then in 2010 or so, we were sort of really pioneers in that area. We started working on that paper bottle, and not knowing where it was going to lead to, because there was really no kind of template for it, no blueprint on how to launch it, and so on. So that, I think, was a really exciting time, because that allowed me to use my paper background, my packaging background, and really jump in and make a difference. Coatings, for instance, also played a big role in that. So this organization, the Advanced Research Organization, I think really propelled a lot of good work and a lot of good research. Eventually, it was dissolved because I think they realized they couldn't have a standalone organization there to roll it into some of the commercial functions within the company. But I think the first, like, about 3 or 4 years, there was a lot of support and a lot of momentum around that. So I think that really created a lot of positive experiences when I joined them. And then, of course, like you said, it's a big company, but I think the good thing was there was a lot of alignment within the stakeholders to really make this change happen. So that helped a lot in driving some of those projects.
So over time, you have gone ahead and worked in numerous areas, like you mentioned paper in passing, but of course, I know that recently you've also been working a lot in the recycling systems
Right.
and plastics recycling. So, with all your experience, let's go stay with the paper bottle. So talk to us, and I'm sure our listeners would love to learn this, talk to us about the benefits of going towards paper from a polyethylene based structure in a bottle, and also the challenges that you see with a paper based bottle, and what is your kind of 2020 hindsight on that?
Yeah, so I think one of the things that actually drove PepsiCo to start looking at the paper bottle was the fact that paper in the consumer's mind is perceived as a more eco-friendly option versus plastic, and I think that's sort of starting to grow now with all the issues around plastic pollution and the issues we are seeing around litter and so on. So paper has a more positive connotation, has a more kind of like I said, a good place in the consumer's mind. And so the idea was, can we take paper or a fiber based substrate and actually create a three-dimensional article or like a bottle out of it that could be recycled along with a paper stream at the end of its useful life. That said, I mean, it was a good concept, and I think we made some good progress. That the challenge is obviously is that plastic is so well engineered for doing what it does, right? I mean, it has the right properties for holding beverages or foods for that matter. It has the right barrier performance. It creates you like a pretty much a hermetic seal when you form the package. So meeting all those requirements with paper or a fiber based package is obviously a huge challenge. So that was something that I think was a learning curve, and I think to some extent is still a learning curve. I know that companies are working on I mean, it's not that difficult to make a three-dimensional bottle, but how do you create the right barrier inside it so that it holds a liquid and also keeps it fresh and keeps it from getting rancid or spoiling and so on. That's I think a big challenge. So I think it's still not a slam dunk. I mean, it's something that's still, I think, under kind of is still under the works. So I would say it's going to be some time before we see a kind of a large scale replacement of plastic bottle with paper bottles. But I think there has been some targeted introductions into the market. So Johnny Walker and some of the brands have done some introductions, but I think a large scale switch to a paper bottle will take some time and may not happen really soon. But I think it's still a very unique concept. I think it's an interesting idea. So I'm really still pretty excited about that.
So pardon our ignorance, but what is an hermetic seal, and how does that matter?
So in that is actually needed in a like a in the case of a paper. I mean, in the case of a snack pouch. So if you think of a potato chips bag, right? You need it has to be sealed properly, but also it has to prevent moisture and from getting into the package, so your chips don't end up becoming soggy and spoiling. So that's where I think you need the right not just the right seal, but also the right barrier to keep unwanted gases out of the package.
And why does that matter in a bottle?
In a bottle, again, I think you need a barrier. For instance, if you're packaging a carbonated beverage like Pepsi, you need the barrier so that the CO2 doesn't escape from the bottle, because I think all of us have had that experience where you've opened a bottle and left it on the counter and it becomes flat, right? After some time, you don't feel like drinking it because there's no fizz left in it. So that type of, I think, a barrier is still needed in a bottle. In other cases like orange juice or other types of juices, you need oxygen from getting into the package, because when oxygen gets in, it starts to degrade the vitamins and also spoil the juice and so on. So you need kind of both barrier from things getting out of the bottle, but also from getting into the bottle. So depending on kind of the specific beverage that you're packaging.
Yeah, it can gets kind of that brownish, rancid kind of
Correct,
structure
correct.
in the orange. So, okay, let's take three substrates, and then of course you've experimented with the paper plus some kind of barrier. You've used a certain kind of polymer from petroleum for bottles, and traditionally there's been glass. So if you look
Right.
at these three materials and you compare them, give us the lowdown on how does Sandeep the scientist's brain looks at it, in terms of pluses and minuses for all three. And if you were if you were to choose, what would you go for from an ecological standpoint?
I mean, it's a little bit of a tricky question with, because the it also depends on the specific situation and the markets and so on. So traditionally, as you mentioned, glass has been one of the materials that been used pretty commonly. Like growing up in India, we used to have glass milk bottles all the time, right? We would finish the milk, take it back, and it would be refilled and so on. Glass is a great material. It has a great barrier. I mean, it keeps the food, or the beverage fresh in it, and you can seal it. The challenge with glass is it's heavy. I mean, you have to really take that into account, especially if you're transporting over long distances or shipping it and so on. Glass can be problematic as in terms of the weight and also the breakage, because it's a brittle material, so it can break and cause that type of hazard. So as the supply chains have evolved, and as actually things have been packed to ship over distances, or people have been carrying things around for more convenience, I think glass has sort of fallen in favor, out of favor, I would say, because of the weight and the breakage issue and so on. Plus, the other kind of disadvantage of glass, in a sense, is that it takes a lot of energy to produce the glass. I mean, if you're recycling it, then if you're using recycled glass, then that really helps, because I think if you're putting it back, recycling and putting it back in the bottles. But what happens is, because of the lot of the breakage issue and all that, a lot of times, at least here in the US, glass doesn't necessarily go back into to glass bottles. It gets kind of downgraded or used for other applications. So that's one of the issues with glass. It's a great material. It's recyclable, but it has this kind of the downside. So it can be, I think, a great solution if it's like a reusable system. Coca-Cola used to have, for instance, I think even in India or in South America, they traditionally had a system where glass bottles could be returned and refilled and so on. So I think it could be a good material for a kind of a refill, reuse type of system. So that's kind of how I see glass. Now, with plastic, obviously, it's everywhere. We are using it in pretty much everything. And I think, again, plastic is a great material from standpoint of performance, from packaging. It's lightweight. It's got low carbon footprint from that standpoint. The challenge, of course, we run into is that it's not meant to degrade, or it's not meant to break down. It just lasts forever. I mean, it's like 3,000, 4,000 years before it even starts to do anything in nature. So I think the one thing I see is plastic will not go away. I mean, I don't see plastic just getting replaced en masse. I mean, there are going to be applications. There are places where, I mean, like bottles and all that, at least in the foreseeable future. Plastic will have to be used. I think what we need to do is better manage it, better collect it, better recycle, or in cases where you can't do it, use it, put it in a managed landfill or whatever. But the idea would be to manage the plastic waste better, as much as we need it. So uh, paper, from my standpoint, is a really great substrate. It's very eco-friendly. It's from trees and from nature and so on. The challenge with paper is it has no barrier. I mean, if you take a paper sheet, it's basically like a sponge or a sieve. I mean, you don't it won't keep anything out. So you need to add other types of materials, sometimes even a little bit of plastic or like bio-based materials and so on, to create that barrier to whatever you're packaging. The other thing to keep in mind with paper is that if you're using it from endangered forests or places where there is kind of large scale cutting down of trees, that doesn't really help because you're kind of reducing the biodiversity, you're eliminating forests. So I think, for instance, what you're doing with using bagasse in your operations, I think that's a great way to kind of bypass that whole issue. Is you're using something that's actually a waste. It would usually be burnt or used or go to the landfill and you're repurposing it to make pulp and paper. So I think the next wave is going to be all about alternative fibers from non wood sources and so on. So I think I see the two ways you can use paper. As one would be from managed or very well managed forests or sustainable forestry, and other one would be using non-wood sources or agricultural waste and so on. So I would sort of put it in that spectrum. That I mean, hopefully, I mean, from what I told you, I don't think there's like one clear-cut choice. It really depends on what you're trying to package, what you're trying to convey, and at the end of the day, you have to do the full life cycle analysis to make sure that you're making the right choice. So it's not just as simple as choosing paper or plastic or glass over something else. I think you have to kind of look at the full picture before you make a decision.
So you mentioned in passing about glass taking a lot of energy to produce, but you
Yeah.
and I both know paper is no saint either, right? So we end up, at least in our plant, which is still agro-based, we end up consuming over 1,000 kilowatt hours or units of electricity for a ton of paper. And then of course there is further processing beyond that if you're to kind of create a bottle. So of course, not knowing so much about glass, but if you look at specific energy and you compare the three substrates again, do you still find that glass is the highest? And the second part, which you mentioned again, is glass the most easy to recycle or the other two?
So I would say, in terms of energy, I would still say that glass is probably the highest. I mean, again, I'm not an expert in on glass, but from what I've read or what I've heard, it's still that's the issue. The other thing too is keep in mind is that it really adds to the transportation cost because you can't really make very lightweight glass bottles, right? I mean, there's a limitation on how thin you can make the glass bottles. So you have to add the carbon footprint or the energy from the transportation as well to the whole equation, which is much less in the case of paper or plastic compared to glass. In terms of recycling, I would say, yeah, from what I've seen or what I've read in the industry, I think glass is probably one of the easiest materials to recycle because all it takes is you just melt it down and kind of repurpose it. In fact, I would say probably glass and aluminum are two of the most relatively the most easiest to recycle because they're called infinitely recyclable, right? I mean, there's really no degradation that's happening. With paper or plastic, every time you go through a recycling process, you're either reducing the fiber length or cutting down the fiber, or in the case of plastic, you're reducing the polymer chain length. So there's always some degradation that happens. But in the case of glass and aluminum, really there's no downcycling that's happening or degradation that's happening. So in that sense, it is, I think, a superior material from a recycling perspective.
Yeah, and you must have probably heard this with your growing up years in India. I don't know if it happens in US as well. But one of the ways, because PepsiCo and Coke had such a rivalry, one of the
Yeah.
ways the local distributors used to hurt the other was to smash the other person's bottles so that they could not be reused. So they would, because obviously in India at least the summer is so strong, and that's where,
Yes.
80% of the sales will happen, right?
Correct.
So they would try to put the other person's stock out of circulation, which is so crazy, right? That how would you do these business practices? So on my next question, I want to like keep understanding from you, keep doing that, going down this spiral hole, and so in terms of when we look at plastic, what I notice is that there is an economic value. So if a rack picker is there, they will quickly collect the bottles. And I presume it's because there is somebody down the chain, which is who's taking it and taking it to a plant where there is going to be, if we don't call it recycle, a downcycle. So typically, what is how does that work? Again, from a consumer standpoint, if I'm throwing away a bottle, what are the chances that it's going to, because you talked about molecular chain, what are the chances that it's going to become a bottle again? Or if not, what does it become, and then what happens from there?
Yeah, so it really depends on the country or the region you're in. Like you said, in India or Southeast Asia, the rag pickers will actually go and pick out bottles from even from like garbage dumps. And in the Western countries, Europe and US and so on, that really is not feasible. So there has to be a dedicated recycling system in place where you have to put it into your recycling bin that you every week you put it outside your home and it gets collected. And so I think the like in places like in India, I think there is a real, like you said, a real value to the plastic bottles, because the rack pickers can take it and actually sell it to kind of the next level up, the processors and so on. And there is a really I think some economic benefit that they get from that. So there is, I think, a good there has been a good movement towards bottle to bottle recycling in India. I've seen a few recyclers who have started, and more recyclers are starting to do that. It, I think, also depends to some extent on what the pricing for the virgin plastic is. I mean, if that is really low, then the incentive obviously would be lower. But in general, there is a good kind of infrastructure in place to go from bottle to bottle. The other thing you can do with, like, especially plastic, the beverage bottles, which is PET, those can go into other applications like carpets or yarn, and also for like strapping materials. You actually can produce like strapping bands and all that can go around bales of things. So there's a few different end uses that these bottles can go into. But ideally, you want to try to put it back into a bottle. Now, nobody actually is make. I don't think very few companies are making 100% recycled PET bottle. So usually there's some version that still has to be brought in, but it could be like there could be like 20%, 30% recycled content in these bottles. In the case of PepsiCo, they had an average of 10% when I was there across their whole portfolio. So again, I think I don't think every bottle that you put out there goes back into a bottle, but I think there is a good if everything lines up, you could go into a full circular type of a ecosystem there. Uh,
So just taking you further, understanding from you further on this, and I'm just picking your brains because you know all these substrates. So the other thing I'm told is that a plastic is not a plastic alone. It's not just polyethylene. There is typically a whole mirage of chemicals, phthalates, and stuff like that. So even when we recycle or downcycle or partially recycle, like you said, there is always that challenge of the chemicals leaching into the system, I mean the ecology. How do you see that? Is that the truth? You see that as partial truth, or you see there is a vagary in that?
Yeah, I think there can be that issue can be there now with plastics that are used for food contact. Typically, they have to go through a pretty rigorous testing. So if you want to get like the FDA, US FDA approval, or in Europe, there's something called as EFSA, European Food Safety Association. To get those approvals, you have to actually make sure you don't have any kind of harmful materials that will leach into the food or beverage that you're packaging. So typically, when you have a food grade package, you are, I think, in a better shape, because you know that it's gone through testing, it's been evaluated to make sure there's no harmful materials. Now, if you are, but then there are other non-food applications. So you have like bottles, the packaging being used for like motor oil or other types of chemicals. Now, there it's definitely a possibility, because that chemical can actually migrate into the plastic, especially polyethylene is really great at soaking up solvents and other types of chemicals. So when you're recycling that, then there is obviously a possibility that some of that would end up in your recycled materials. So there has to be a really thorough cleaning or decontamination that has to be done before you can reuse it for any food applications. But yeah, you're right. I think in non-food plastics, there's a greater possibility of some of these chemicals or hazardous materials kind of making their way into the chain.
And when you're forming a simple soft drink or a water bottle, would there still be a lot of chemicals required when you are actually forming that stem, right, that gets blown? Does that also require a lot of chemicals to be able to hold that pet? together? And the second part of that question is because this word keep coming up and I have no clue what that means is phthalates. What are those? And do they form a part of that structure? And then what happens if you're say downcycling it into a yarn or something like that?
So actually, the stem or the stem and the rest of the bottle are actually all formed in a single process. It's something called as injection stretch blow molding, where you essentially the way it works is if you think of like we use test tubes in our schools, right, for doing chemistry experiments. So you form something that looks like a test tube, but it has a like the at the top of it, it has those threads, the where your cap will go in, and then you take that and you blow it into a bottle. So you're actually forming both the top of the bottle and the body of the bottle all in a single process. So you don't really need any chemicals to during that process. It's just the resin, this kind of test tube, which is called a preform, which is blown into that. Typically, the PET bottles don't really have any phthalates. Now, one of the things that could happen is under maybe high temperatures or some conditions, it could potentially result in phthalates. But I've not seen any major issue with, especially with PET bottles, with presence of phthalates. Now, other polymers there could be a possibility, or if you've added something to the resin to for certain properties and all that, that could be possibility. But again, I'm not very familiar with production of phthalates. I have heard that as well, but I've not seen it in the case of PET bottles for sure.
So let's switch to paper now. So it's been 15 years since you did your set of direct experiments. I know you've been involved with various people in that domain. But if you look at the evolution in these 15 years, the experiments that you did in 2011 versus what you see now in the market space, how much has it really evolved? And what are you seeing as the challenges with it really reaching scale?
So I think what has evolved is that the I think the understanding of the designing how the substrate can be produced has changed. So to give you an example, paper traditionally has been like I think has been an open porous material. It's been produced on a large scale in large tonnage. Over the last, I think, about 10 years or so, people have started working on how do you optimize the paper by changing the surface or making it a more specialty type of substrate so that you can actually get some of the right properties from it. So there's been a growth in more specialty papers in the last, I would say, decade or so. It's not just all just brown paper or just kind of printing papers and so on. The other thing that's happened is that there's been, as you've seen, there's been a shift away from printing, like actual physical printing, right? People are printing less and less as you're going to more digital. So that's reduced the focus on printing papers, and people have been switching more towards packaging as an application for paper. And so that's another reason why things have evolved the way they have in terms of optimizing the substrate and trying to look at the ways to make the paper more functional. Other thing that's I think evolved is the whole barrier coating area. I mean, I started working on it maybe 15 years ago, but it was the understanding of the barrier coatings was not that good. But I think as things have progressed, people have found out ways to design right up barrier coatings. How do they interact with the surface of the paper, and how do you optimize the barrier performance and those type of things. So combining paper with either some sort of a coating or lamination, I think that has really evolved and changed over the last 15 or 20 years to a point where now you can actually match the properties of a plastic package with a paper with maybe a certain amount of coating. So I think that has really come a long way.
And when you look at, what we are seeing now is a lot of molded fiber, the pulp molding
Right.
side, and both the wet molding and the dry molding
Yeah.
systems. So, how do you see that evolution in the last 15 years? Because you're seeing a lot more of it. And what is stopping that from truly scaling and really being a great alternative to what is available right now?
Yeah, so again, molded fiber is not new, as you know. I mean, it's been around for probably 50 years now. The difference is that the old processes or the previous focus used to be on just making like egg cartons or like some of the really low end or really kind of rough structures, or for like insulation, right? I mean, for people would use it for like creating insulating properties and so on. So what has changed over the years is that the process for making the molded fiber has evolved, where you can make now really make smooth, high end type of packaging. I mean, I've seen some molded fiber packaging that really comes to almost close to a plastic package in terms of the surface finish and smoothness and so on. I think some of your the packages that you make, like in with Chuck, I think are actually very similar to like a plastic bowl in a sense in terms of the look and so on. So I think the whole process, or how the way of making the package, the bowl or cup or whatever, and then pressing it and getting the right surface finish, I think that has come a long way. The other thing that's really also evolved is creating the barrier within the molded fiber. So whether it's an internal barrier in the fibers, or adding a layer of lamination or surface coating and so on. So I think there's been a lot of evolution, and there continues to be an evolution in applying barrier to molded fiber. So I think it's really got a promising future. The one, I think, the big limitation I see with molded fiber is the production rates, because it's still a it's really a batch process, right? With plastic packaging, you're almost continuously producing these. In this case of molded fiber, it depends on kind of how many, I guess, cavities that you have. I mean, how big your machine is and how many pieces you can make. So I think as that scales up, and I think you would have to look at a faster process to be able to produce these at scale, because it's still, if you think of it, the molded fiber tray compared to a plastic tray, there's still a cost differential, because you're not producing it as fast. There's maybe a little more material that's used and so on. So I think scaling up the molded fiber process is going to be the critical piece in terms of getting it to an economic parity with plastic packaging.
So you mentioned barriers, and I know that you've again looked at over the years, looked at so many different ideas, and I presume maybe in 2011 it was still a petroleum-based laminate or something like that. So where do
Right.
you see the most promise, especially when it comes to a pulp molded bottle, which is getting so much buzz right now with Carlsberg, and you mentioned some liquor companies and all of that. So considering the buzz they are getting, and assuming that it's a biodegradable barrier, what would that structure be for you? What is the ideal structure as it stands today? That this is the direction most companies should go for, according to you.
So it really depends on what you see as the end of life for the package, the bottle, or the molded structure. Is if you look at it from a recycling standpoint, you want to make sure that you're able to recover the maximum amount of fiber from the package, and then the whatever the barrier material is, either it disperses in the water or can be removed cleanly from the fibers. And I still think that recycling is by far the most practical end of life for packaging, because you're kind of maximizing the value of the fiber in the package. So from that perspective, I think my the way I look at it is you want to have as much fiber in the package as possible, and maybe a minimal amount of barrier material, whether it's a bio, I mean, typically a bio based or something that's more renewable to keep the carbon footprint low. So, in terms of the other possible end of life is compostability, and there, I mean, you want, obviously the barrier has to be compostable as well. I mean, paper, like fibers typically are not an issue, because you know that the paper based package is compostable. But any type of barrier that you're applying also needs to be compostable. The challenge with composting is that the availability is still pretty limited. I mean, if you think of even European countries, or in the US, the collection and industrial composting is still very limited. So it's a good end of life option, but I think it's something that will require some time to really develop. Ideally, what you want to have is something that can meet both needs. Both It can be both recyclable and compostable. So depending on what part of the world you are or what region you are, it can go to either type of process. So that would be my preference, is design something that would be both recyclable and compostable at the end of its useful life.
And if you're creating a multi-layered substrate, like we're talking about, like you explained to us that paper is inherently porous, and
Yeah.
hence there has to be a barrier. So obviously there'll be an interaction of two substrates. What you also explained to us is that these stems, the preforms, are basically a singular monostructure, which is much easier to transport, etc. So, do you think we are increasing the complexity in recycling, even if it's downcycled or partially recycled in case of plastics, in case of PET, are we increasing the complexity by going for paper plus another substrate?
So it depends on how much of this how much of the other layers here you're applying to the substrate, and that's one of the reasons I said is that my preference is to have as low amount of second material on the paper, because at the end of the day you also want to maximize your fiber recovery. So when you're recycling it, if your, let's say if your package is like only 50% fiber and other 50% is uh, coatings or laminations or whatever, you're only getting half of the package back in terms of the fiber recovery, and that is not a kind of an acceptable solution, because most of the recycling standards call for at least like 85% plus recovery. So I think the idea would be to design your coatings or your and also your substrate. So you optimize your substrate and the coating so that you don't have to apply a huge amount of the coating on the paper to get the barrier. So you're still balancing the fact that it's mostly paper and maybe a small amount of kind of either a polymeric material or a bio-based compound. So that would be the way that's the way I look at it, is how do you maximize the fiber content in the package.
And you mentioned the ideal state, which is both recyclable and compostable. So, do you see, because you're so well aware of what is happening in the industry, so do you see a promising substrate that will kind of solve for this challenge in becoming the right barrier and providing both those ideas of compostability and recyclability while performing, considering that there may be certain acidity in the material inside, whether it's a carbonated drink or alcohol or other properties that you see that have to be a certain kind of barrier? Is there a material that you see that is doing the job?
So there's one thing I tell the companies or people I work with is that there's no one single solution that will meet everything. The thing with plastic is it's almost like a bulletproof material, right? You can use polyethylene from everything from potato chips, I mean, or polypropylene from potato chips to dry foods or other types of products. With when you switch to a paper-based package, you really have to kind of segment it. So you have to maybe look at areas where you don't need as high a barrier. The way I look at it is, if you think of like something like potato chips, that's the most demanding application. And I somehow don't see a paper-based package completely switch or completely switching to paper-based package for that type of application, because the barrier requirements are really high. But if you're thinking of something like a dry granola or some kind of a dry food or snack where you don't need as much of a barrier, there you can get away with paper with maybe a slight amount of barrier coating. So I think depending on kind of what you're targeting, you could achieve that combination. And I've seen, I mean, I think you have also seen companies like Mars and some other confectionery companies actually have replaced their plastic pouches for their I think like candy wrappers or for their granola bars and so on with paper based package. So I think it's possible to do that. Again, it's not a one size fits all solution. You have to really be targeted in what you're trying to achieve and whatever product you're packaging. So I think that's a big learning moving from plastic to paper in some of these applications.
We're going to dig a lot deeper into the multi-layered substrates. That's a whole section for you. But I'm going to keep picking your brain on one more subject, and then we can switch from bottles. And I know I'm going to learn a lot in different structures. So why not? Why complicate it so much by going for a pulp mold and a barrier and a 3D structure where barrier is a challenge? I've seen people create a pulp mold on the outside and put a poly bag on the inside so the customer doesn't see it, but it's still a polyethylene kind of structure. Why not go in for a biopolymer? Why not just create a PLA bottle or a PHA bottle or something like that? Is that not a feasible structure, or is that still in the making?
Well, one of the challenges with, and that has been actually done in the past, like making a bottle out of, like a beverage bottle or a water bottle out of PLA. The big issue with that is that it really confuses the customers or consumers. So especially when you're putting it into your recycling bin here in North America, people don't know that it's PLA versus PET, and then the recyclers actually run into a problem because PLA melts and causes all kinds of problems when you're recycling PET. So in fact, several years ago, I think a few decades ago, actually, NatureWorks did look at that, and they decided not to enter that market because it was causing recyclers a big headache in that sense. Now, it can be possible if you actually make the bottles and create a closed loop collection system. So there have been some efforts in Italy, for instance, a beverage or a water company there in Italy created a whole closed loop system where they would collect these bottles and either recycle them or compost them without mixing them with PET bottles. So, but it requires kind of almost a dedicated collection and sorting system and all that, which in large scale is not a possibility. So, the use of bio-based materials for beverage packaging, especially, is kind of fraught with some problems that I think people have looked at, and they kind of decided not to go down that route uh, several years ago.
And I promise my last question on bottles. At least I know my promises haven't held till now because it's so interesting to hear from you. But but looking at the cost side, which you mentioned again before, when we look at a soft drink like a Pepsi bottle, it's a very different price point from a Jack Daniel's bottle. So do you really see a wide adoption? If like your first point, if we are able to sort for the production ability, and somehow by magic the cycle time goes from 60 seconds to 6 seconds or something, and we can produce a lot of bottles in bulk, and we can create a barrier very quickly. So let's say we do all of that. Do you see the price point being in the ballpark where somebody would be motivated economically to switch from a PET to a paper bottle? Or will it always be a higher end application where it's much easier for them to justify the price?
Yeah, I mean, I think at least in the short term, I mean, or even maybe in the medium term, I see it as a very targeted market because I don't see with a plastic bottle, given that the plastic bottles have had a learning curve for almost like 50 years now, right? They've been around for a while, so they've gone through that the initial teething problems and all that, and now it's come to a point where it's all like streamlined and produced in large quantities. To get to that point with a paper bottle, I mean, I see a minimum of, like, I would say 20, 30 years, even more, to get to that. So I would in the at least in the short to medium term, I would say it's going to be on a very focused basis. So like you said, Jack Daniel or something which is a very high value item. The other thing to keep in mind is when you have these three-dimensional paper bottles, when they go through a recycling system or especially a sorting system in a material recovery facility, they actually would end up in along with the other plastic bottles because there's something called a 2D 3D sorting, which actually sorts flat packages from something that's more three-dimensional, and the paper bottle would end up along with the three-dimensional plastic bottle. So once it's gone into that stream, the other challenge is how do you take it out and then make sure it goes back into the paper recycling, right? So that's one of the things that a lot of companies are now still working on, and there's a lot of investigation that's going on in that field. But one other thing to keep in mind, it's not something that can be crushed into a two-dimensional shape and go with like normal paper. So you have to really keep that into account.
Yeah, it's definitely an additional complexity. I'm going to switch from beverage bottle to beverage because I know you have this plethora of experience leading Starbucks Cup Challenge. So that's been something that you've been passionate about and worked closely with them. That's another huge behemoth. Seems to be people who really care in terms of the substrate that they're using. And, I know that you were so involved with that whole idea of finding alternate materials. Would love for all of us listening to hear that whole journey and what that was like, the whole how did you connect with them, what was that like, where did you reach in terms of the effort that you made for so many years, and it continues. I know it's not yet done.
Not done yet, yeah. So the way it actually all started off was when I jumped from PepsiCo to the consulting career. I had some good connections with Starbucks through my industry network and so on. And essentially, they approached me and asked me if I would be interested in helping them with the kind of looking at sort of this next generation of coffee cups and helping them kind of the efforts that already they had underway, and kind of lead it from a technical standpoint. So I got involved with that and started working with Starbucks. And then along the way, they kind of realized that it was not something they wanted to do on their own. They felt that this was I think, an industry challenge that required some collaboration. So they actually brought McDonald's on board as a second partner and formed this cup challenge. It was called the NextGen Cup Challenge. And then there was about another probably about 8 or 10 food service companies that joined in. So you had like Wendy's and KFC, some of the other leading companies that in that field actually joined in. And the idea was that you create this consortium or a collaborative effort where you can look at ways of scaling some of these solutions, which could be maybe further out, but then you can look at things that could be taken and scaled up to create a solution. The idea being at the time to make a coffee cup that would be fully recyclable and also compostable. So again, keeping both end of life options in mind. And I became involved with that consortium pretty early on, and then I've been a kind of a technical advisor for that consortium, leading the initial evaluation and scaling of some of these solutions. Over the years, what has changed is that I think earlier on the focus was looking at any type of material, whether it's synthetic materials like latexes or acrylics and all types of different solutions. Over the years, the preference has switched to more bio-based or renewable materials. So over the last maybe 4 or 5 years, we've been pretty heavy, actively looking at PHAs, for instance, and then we also, in the initial stages, looked at bio-PBS as one of the options for cups. In fact, Starbucks actually launched some cups in, like, I think, a couple of markets with a bio-PBS liner. They did some test market. But what happened was this was just before COVID, and once COVID sort of hit, they had to kind of pull back on their plans. So it was never actually commercialized in a large scale, but there were some good learnings from that. So that led to some of the work that we're doing now with PHAs and other types of biopolymers. And so I think the kind of the next phase of the cup challenge is focused on two things. One is looking at bio-based renewable materials that could meet the requirements, and the other part of it is given the focus on plastic-free alternatives in Europe. There's a whole as you probably are aware, there's a whole single-use plastics initiative, what's called SUPD in Europe, which is requiring special labeling and kind of also wants to get rid of certain types of single-use plastics. So there's a big interest in plastic-free cups and how do you develop those and what are the options for that. So those are the two key focus areas right now for this cup initiative.
And Sandeep, were they all just coating replacement, or did you go beyond that? Did you also explore, new monostructures or some other materials, and or did people come in with those ideas too, and how feasible were they?
Yeah. So one of the areas we looked at pretty heavily was molded fiber cups. So you're familiar with Footprint. I know that they were big, and they unfortunately went through some challenges over the last few years. But they were actually one of the finalists, or they were one of the winners of the cup challenge early on. So I've actually worked pretty closely with Footprint on some of the molded fiber cups. The other thing that I think there were actually some ideas or some solutions that came through that were based on like a seaweed based compounds. There was a company that had developed, I think, cups out of seaweed based polymers. Unfortunately, I think the scale, they were not able to achieve the scale or the requirements that we were looking for. So there have been other materials, other types of concepts that have come about, and we continue to look at other as this initiative evolves. We continue to look at other materials that would meet the requirements, especially if they can be considered plastic free. So, for instance, the Notpla material, we've been in contact with them, and I think they are working pretty actively on cups in Europe now. So some of those type of, I think, initiatives we continue to monitor and kind of bring in as they make sense for cup applications.
We would like to take a minute to thank our sponsors. Good Garbage is sponsored by Paka. a family of brands that produces compostable packaging and works to implement regenerative solutions. Paca's new project is to bring compostable food serviceware and food carry products to the North American marketplace. Learn more at paca.com. Now back to the conversation. So, what are the challenges with molded fiber? Footprint aside, of course, you understood the molded fiber also. So, what are the challenges that you feel that why not just switch to a molded fiber cup structure and call it good?
Yeah, so I think the key issues we saw was again getting the right barrier. I mean, the barrier performance in the cup, especially for like hot drinks like coffee, ensuring that it's not seeping through the cup and causing those issues. The other thing we saw was that the cup weight was actually significantly higher when, especially the work we did with footprint compared to like a conventional paper cup, like a Starbucks cup, which is like maybe like 12, 13 grams. With a molded fiber, it was really hard to get below like 20, 25 gram cup. So that adds a significant weight component to the cup. So I think some of those things have to be really worked on and fine tuned before you can see wider adoption of molded fiber cups. The other thing I've heard, I mean, I think again, it's maybe sometimes a perception issue, but consumers sometimes had some mixed feelings about drinking coffee from a molded fiber cup. They, so depending on, I guess, the fibers that were used and so on, they felt that there was some residual taste or kind of odor from that. So I think again that's something that might have to be looked at as you start rolling out these cups more broadly.
What about the aspect of there is always that challenge in a molded fiber for printing? Is that something that people had solved and it was okay? Could you print at scale? And I guess for a company like Starbucks or Wendy's or McDonald's, that brand presence would be important. And of course, distinction from each other as well in terms of what their cups look like. So was that an important aspect as well, or was that solvable?
No, I don't think we got to that point where that was solved. I mean, I think the focus really was on getting the right performance and so on initially. Now, one thing to keep in mind is that this cup initiative is actually like a pre-competitive collaboration. So the idea is to that we would do the evaluation and make sure it works, and then kind of let the brands take it and roll it out on their own. So we never really got to a point where we could actually look at the printing. But you're right. I think I think there has been some developments or improvements in printing on molded fiber substrates. But I think that again needs to be tested and how consumers see it in terms of the graphics and so on. We haven't really done that to any large extent.
So the other thing I see when we look at a traditional paper-based structure, that it's not really just paper-based, right? There is a multi kind of structure. So of
Yeah.
course you laminate or extrude a flat sheet, you turn it and make it into a cup, you put in a bottom, and you put a ripple deck for insulation. Is there ideas that came across where you could do away with this multiple kind of substrate structure and multiple process structure? And why I'm saying this is because we did a little bit of work with foaming natural materials. You've worked very closely with cellulose acetate again and PLA foaming and, looking at starches and seeing how that. And of course, we had our own challenges with structural integrity and stuff like that. But were there things that could be so in a way mimic a styrofoam cup, but in a biodegradable and a natural methodology? Is that a rabbit hole you've gone in?
Personally, I have not. The focus always has been on replacing the polyethylene liner with something that would be easier to recycle. Now, having said that, I know that one aspect of the cup initiative, the consortium, was also looking at reusable cups. There, actually, we did look at some. There are cups that were produced by foaming polypropylene. I think there's a cup called Bocatec from Europe, which actually uses, I think, like a proprietary foaming technology for polypropylene. And we had evaluated that. In fact, I think Starbucks was looking at that for some of their markets and so on. So not on the paper side, but on the plastic side, I know there's been some work that has been done on foaming to create an added layer of insulation. But I mean, yeah, if there are ideas that we could look at from foaming in a cellulose based structure, I mean, definitely would be open to considering that.
And how bad is, EPS gets a lot of flack for what it is. But considering, so if we compare, now there is a multi-layered structure of paper plus polyethylene versus there's a lightweight, 98% air styrofoam structure that is very versatile. Why would we not just stay with that? How does that cause more harm than the paper structure?
Well, the thing, the challenge is with the recycling of the EPS. I mean, there is very limited recycling infrastructure. There are places which will take EPS, and then they have to. The point is that it's so lightweight, right? By the time you collect like maybe a few thousand cups, the weight itself is very low. So you have to then compact it, reduce the air in the material before you can take it and recycle it. So some companies and some places are doing that, but it's still very limited. So that's why you have things kind of lying around. I mean, you see styrofoam cups kind of floating around in water and other places. And so I think it's really comes down to the recycling challenge or a processing challenge at the end of the life, versus a cup which has maybe even a polyethylene lining actually can in principle be recycled, because a mill can take it and repulp it and remove the polyethylene. I think that's been one of the big drivers for not moving to styrofoam or EPS cups, is because I think the not less than ideal end of life for some of those cups.
Did you look at both hot and cold usages, or was it mostly just hot? And how much difference is it in those? Of course, you see a lot of difference in size, and in colder applications, I see more monostructures as well come in, whether it's that solo red cup or a styrofoam cup as well. But in the hot cups, it's mostly paper plus. So is that? Did you look at both? And does the usage? How does it kind of determine the structure or the substrate as well?
The focus of this cup initiative is both hot and cold cups. Traditionally, cold cups, the cold beverage cups, actually are somewhat even harder to recycle, because there's also a layer of a poly on the outside to kind of prevent the condensation. I mean, actually, what it does is basically, if there is any moisture that condenses, it just rolls down the side of the cup. Because if you don't have that outside layer of plastic, you can actually make it more soggy and harder to handle. So you actually have a cup that now has both polyethylene both on the inside and outside. So in a sense, your amount of fiber in the cup now goes down compared to a hot beverage cup. So we did look at both and kind of look at ways in which we could replace the liner both outside and inside, and also maybe try to eliminate the outside liner if possible. So yeah, the focus was on all kinds of cups within this challenge.
So I'm going to pick your mind to a similar idea that I had before, and because you've spent so much time in India as well, because it's such a cost-sensitive market. You see these, little chai cups that are literally so flimsy. It's like a flimsy paper with a polyethylene lining, and it's used so widely, right? It's like not even pennies, right? It's so cheap. But what I'm told is that that's a very dangerous substrate, not just from a handling standpoint, but more because the polyethylene may not be as clean, and with hot liquid inside, there may be a challenge of, again, chemical intake. Is that reality, or it's more of just kind of rumor mongering that happens?
So again, it depends on how strict the regulations are in terms of what you can use, the type of polyethylene that can be used. If the regulations don't really drive too much of testing and so on, then you could run into some of those issues. I would think that if it's being used for like those type of applications, there has to be some oversight on the quality of the polyethylene that's been used. I mean, especially when you're making those cups, you have to extrude the polyethylene on the substrate. So the grade or the type of polyethylene that's being used has to be something that has to be designed for food contact. I'm not familiar with what type of resins are being used in India right now. I mean, I've actually, like you said, I have spent time there and had chai from those cups. So, yeah. And I've lived to tell, I guess, in a sense. Let's see.
At least there's no immediate effect that you've
Exactly.
had. We'll see in the future. There's this
Yeah.
other interesting thing which recently happened with all the crisis that is going on in terms of petroleum. India actually mandated that slowly we're going to go to 40% recycled content in food packaging, which is such an interesting mandate, right? And especially in food packaging, you tend to avoid recycled content, but India has, I guess, within the rules, but so it may be cleaner kind of recycling, who knows. But is that something smart to do in terms of reducing the overall content of virgin materials, or do you think it's dangerous to put recycled content in food packaging?
So again, it depends on how good of a recycling operations that you have. Like I visited some of the PET bottle recycling facilities in India. There's some near Hyderabad, actually some of the leading ones, Sri Chakra, and some of the leading recyclers, and they have really have state of the art process for cleaning and decontaminating the PET, and I think that's one of the reasons that the government of India actually changed its position till about I think five. I'm trying to think about maybe 3 or 5 years ago. There was no recycled uh, PET that was allowed in food or beverage applications. But I think they changed that and they realized that the process had come to a point where now they could feel comfortable that this was meeting the requirements, like especially the international requirements for recycled content. So it really, I think, comes down to the fact is if you have state of the art or a kind of good quality recycling plants that can handle some of this contamination and so on, that can remove it. I think it's a smart move because then you're reducing your dependence on virgin plastic, right? I mean, you're then making sure that more of the plastic is kept into a circular flow rather than dumped out or thrown into landfill and those type of things. So I think it's a good policy as long as you have the right processing equipment and factories in place to handle that.
Good to know. The one thing which I kind of said that we'll come back to, and that's the kind of elephant in the room, and I really want to pick your brains on this one. Also because you introduced me whatever 10 years back to Brad, and we had a lot of conversations around multi-layered plastics, and you guys had used PLA for sun chips so early on, and actually successfully. Do you see this big challenge of multi-layered polymers, which you said, 1,000 years for a cup, maybe this is whatever, 100,000 years for a multi-layered structure. Do you really see this getting solved in terms of first performance? Because if it doesn't perform, then anyways, it's not going to fly. And then being able to come down to a cost parity where people will adopt it widely. How do you see that evolving?
So one of the areas, like you mentioned, Pepsi has been very active in is developing a compostable structure because I think what they realized was that you cannot maybe completely move away from plastics in some of these high demanding applications, potato chips and so on. So they started working on the PLA plus, I guess, some other layers, and then over the years. They've had collaboration with the PHA industry to produce PHA based structures as well. So I think there's been good success in creating a fully compostable structure. I think one of the things that's limiting wider adoption, obviously the cost is still a factor and it's higher. But apart from that, I think the other thing that's limiting it is the not having widespread access to composting for some of these packaging, because the number of industrial composting facilities in US is still quite limited, and I think it's the same is the case with other parts of the world. It's growing, but it's going to take some time. The other piece is that there's been somewhat of a pushback from composters to accept some of this packaging because they really want the food, kind of the actual primary food and so on, that they can really create value out of. So I think the number of composters that accept food packaging is even smaller than the overall number of industrial composters. So that's been, I think, one of the limitations in kind of scaling it. But as I see, I mean, if the composting facilities grow, and especially if more and more people are able to do it at home, that's one of the reasons you see kind of this push towards home compostability. Is, I mean, the fact that it creates another option where you can put it into your backyard composting pile, and if it breaks down and causes or doesn't cause any microplastics and so on. That would be another way to handle it. So I think there is starting to growth that's starting to happen, but I think there are still some of these obstacles that need to be overcome before it becomes mainstream.
So two things from what you're saying. As an organization, we said at least all our products cannot be packaged in polyethylene or HDPE. Let's move towards PLA, because if we don't adopt it, who will? Kind of thing, right? Even if it's whatever 100% more price or whatever.
Yeah,
So we did that. But Sandeep, we really faced a huge challenge, and it was basically because one, of course, in order to reduce the cost, we went a little thinner, so that we can at least have maybe 50% additional cost instead of 100%. And
yeah,
then we got so many complaints for disintegration on the shelf. And of course, we're talking about a different temperature kind of level and maybe handling as well. So that was a huge challenge for us. And the second part, in terms of performance, so of course, you know that we've been experimenting with this idea of paper-based structures with different substrates.
right.
So the other fun, it's not fun, but the other challenge that we had was, even if the paper does the performance along with the barrier, there is a puncture issue. So as soon as there is even a tiniest puncture, there is going to be infestation, especially if it's a sugary substance inside. And
Mhm.
that became a havoc. So if it's a primary packaging instead of a binary packaging, then it was again another challenge. So how do you look at this challenge and of course, from a packaging standpoint, the dharma is protect what is inside. So if
Correct.
both these things happen, how do you solve for that kind of eventuality?
Yeah, I mean, it's. I think it's tough to anticipate every single issue and situation. Like you said, the puncture or the tear can be a challenge. I mean, there are ways to sort of get around that with maybe high tear substrate. So there's like the extensible papers and companies that are actually in fact using it. So Amazon is using it for some of their mailing applications and so on, where they want to switch away from plastic to paper. So they're uh, it's a higher cost, obviously, compared to the conventional mailers, but I think they're willing to do that. So there might be ways to do that. Again, I think it comes down to, I think you don't have a single solution that will meet all your needs. You really have to tailor the substrate and the combination of the substrate and the coating to get kind of the optimum barrier plus whatever mechanical performance that you're looking for. So I think people in the past have been just saying, okay, let's take this paper and apply coating and then see what happens. But I think more and more I'm seeing a need for developing maybe more specialty or kind of special grades of paper, which will be really tailored for some of these type of applications.
Yeah, that's such a brilliant observation, Sandeep, because I keep seeing people trying to mimic what is there, right? So what you end up doing is that, or take a paper that is relatively non-porous and
Yeah,
then add a layer for moisture, add a layer for oxygen, and maybe a heat sealant or within that, and voila, you have something. So what you're trying to do is you're trying to solve the challenge by mimicking what is the way we are handling it now, but you're right. Paper doesn't have the inherent properties of stretch and tensile and the natural barrier that comes with polymers. So if you are to solve it, let's take a case. Say you want to solve a challenge like you mentioned, a nice chocolate bar, which is sold not in a box but singular primary packaging and call it good. The printing is on that. There's only one layer. It's like a Mars bar. Let's take Mars as an example. So
okay.
Sandeep, you have your doctor's hat on, and you say that, okay, I'm going to solve this. How would you design that paper? And knowing that you are ultimately a deep kind of understand, you have a deep understanding of paper, what would that paper structure be? And then how would you design the barrier chemistry, including internal and external chemistry?
So I think the way I would look at it is, first of all, what kind of performance or barrier does it require? I mean, some of these packages are actually sold within 6 weeks. Some are sold within 6 months. So depending on, I guess, how long does it have to stay on the shelf? like a pack of potato chips, right? I mean, I don't think anybody will keep it around for like a year or more. That's a sort of that's why they call it FMCG, fast moving consumer goods, because it gets rotated on the shelf pretty fast. So starting with kind of what are you designing for? I mean, what kind of shelf life are you designing for? Is I think a crucial thing. So I would look at that. And then of course, what kind of things does it have to resist? I mean, what are the type of materials in the food itself, right? So if it's like fresh nuts or fresh kind of or other types of materials that require prevent oxygen from getting into the package, otherwise they'll get rancid. So I would design the package so that it creates the right kind of barrier for the food that it's supposed to contain. Again, also depending on what kind of handling situation you it's going to see, if it's going to just sit on a shelf and somebody picks it up and puts it in their cart, versus is it going to be shipped across long distances, it's going to be thrown around or dropped and so on and so forth. So again, depending on that, I would look at what sort of paper substrate or what type of material that I would start with to design for that. So again, I think you really have to kind of narrow it down to the actual food product, the end use, and what type of transportation and those type of things that you are looking at. So I think that's when I do some of these projects with companies, I kind of advise them is look at that the whole value chain, not just the barrier itself, but what is it going to go through, what is it going to look like at the end of its life. So those type of things. So looking at it holistically rather than just looking at purely from a barrier perspective is the way I look at it.
So I'm going to push on you a little bit more. So
So
Mars bar, Mars bar being sold in India. I'll take a more harsh temperature and condition like a open shop. So Mars bar being sold in India, and they are desperate to remove their current structure. And they want to go for a new structure. Let's not even put paper there. And Dr. Sandeep Kulkarni has been contacted and said that, Doctor, you know it all. You understand paper. You understand biopolymers. You understand the challenges of India as well. So, what would Dr. Kulkarni do? And they say that, okay, we do have a cost challenge too, but we'll give you freedom around the cost. We'll give you cost freedom, but not extreme freedom. So what would that be? What would that solution be? Or what is, I wouldn't even say solution. What is the direction you would take them at?
okay, so like I said, for Mars bar, I would try to understand what is the current for instance, how long do they need to keep it on the shelf? Is it sold within a like a few weeks? In which case, you don't need something that will keep it fresh for a year or more. And then, what type of really what type of things are important for keeping it fresh? I mean, so you would typically need like a Mars bar. You would probably have some oil. There might be some oily components to it. And given the Indian conditions, obviously you want to make sure that whatever you're using actually is performing at the kind of the temperature extremes. So oxygen barrier is one where you actually lose a lot of times you lose oxygen barrier when you go to like high temperatures and high humidities. So even things like EVOH, which are really good at room temperature, you when you go to high humidities, you start losing that barrier. So using something that would actually then perform at the kind of the extreme temperatures. I mean, I think there are kind of new materials, new polymers that are coming in that can give you oxygen barrier at kind of more wider range of temperatures and humidities. So looking at that, and then of course the other piece is, I think I know that one of the points of failure I've seen in the case of like chips bags and so on is you actually lose in extreme conditions. You actually lose the heat seal, so the bags actually can pop open. For instance, in the case of Pepsi or Frito-Lay, they actually use a really strong adhesive to make sure it stays stuck, even like when it's being sold at the petrol pump where there might be fumes and so on. So if you look at it, for instance, in the US, if you buy a potato chips bag, you can actually pull it apart. You can open it by just pulling it apart. The bags in India, you can't do that. You actually have to tear them to actually open them. So things like that, I think keeping that in account is using the right adhesive, the right kind of material to seal it so it doesn't pop open under those extreme conditions. would be the other piece. And then, of course, I think looking at how to combine some of those materials with, especially if you want to go to a paper-based substrate, combining with the right substrate. So, like you said, if you want that the package to withstand kind of extreme conditions, then I would go with like maybe a higher strength substrate that would be able to withstand like maybe puncture and those type of things, and combine it with those coatings. So I would look at maybe I think set up almost like a really a design of experiments or a kind of a spreadsheet to look at a series of materials, look at the barrier performance, the end of life, and also the printing. Like you said, it's important to get the right printability. So it would be almost like a matrix that you have to look at with combining these, and then maybe do some initial evaluation and see how those perform. Uh, but I think by far the barrier is probably the biggest challenge when you get to some of these type of sensitive type of foods and so on.
So you wouldn't have thought this, Sandeep, but I'm going to up your degree of difficulty.
Okay.
knowing your complex brain. So I'll take you back 20-25 years to your deep kind of paper background where you worked with amazing companies, Nina, and companies that are really cutting edge kind of new materials and exploring different directions and not being limited by purely what is available.
Yeah.
Mars comes back to you, and Mars says that, sorry, Sandeep, we cannot have barriers like coatings. We want you to play with internal chemistry and create a monostructure which is still compostable and does the job. Is there a methodology that you would take them then, and knowing that it is still a Mars bar, and maybe
Mhm.
they say that, oh, we are willing to compromise on the shelf life, maybe we don't want you to create for a year, we want you to
Right.
create for 2 months. 2 months is enough. Can you go back to your lab and play with the paper itself and build internal chemistry so that the surface is closed enough that my Mars bar survives for 2 months? Would that be what? I won't even give you that option. I was going to say, would that be an option? I would say that is the direction they have requested you to go. So how
Right.
would you go about tackling that?
Yeah. So one thing I will say is there is only so much you can do with the substrate itself. I mean, you can definitely make it more closed or less porous and add maybe some chemistry to the substrate. But I think again, given the fact that paper is basically cellulose, there's really no way you can make it like especially moisture proof. I mean, there's unless you put some sort of a coating or treatment. Now that said, there are things like microfibrillated cellulose, MFCs, and basically which is nanocellulose. There's been a lot of good advancements where you can add those into the paper as a part of the substrate, or as a maybe just as a surface coating, which will give you actually really good sheet, but also to some extent oxygen resistance or oxygen barrier. I know that nanocellulose has a really great oxygen barrier. But when it comes to moisture, I think that's where your real challenge is, because cellulose it just loves moisture, and unless you really impregnate it with something, there are actually ways to make a waterproof paper, but then you have to really soak it with something that, for instance, to give an example, at Nina, when you mentioned about Nina paper, I was there. We were making actually label paper for like things like Levi's jeans, kind of the label, the thing that goes in the back of Levi's, the one that says Levi's and their logo and all that. That's actually a paper, that was a paper substrate, but then they used to impregnate that with a latex to a point where it almost felt like a plastic, and it was really water resistant and so on. So, but at that point, you kind of have to ask the question: is it still paper, or is it mostly plastic now? So, you could do something like that, I suppose, where you can actually have basically incorporate a material into the paper. The other downside with that is that that would not be then recyclable. It would be very hard to recycle with something that level of latex. So again, it comes down to a balance of what you're looking for, what sort of end of life you're looking for. Um, so I think, from my perspective, I think creating a moisture barrier inside paper does require some additional coating or surface treatment. You just can't do everything in the paper itself.
No, thank you, doctor. That was a very well structured kind of answer. And for the listeners, actually, Sandeep stayed very true to to my push, because you actually talked about surface sizing. You didn't talk about surface coating, which was brilliant. Because surface sizing we can still do on the machine while the paper is wet, rather than adding another layer on top. So that's brilliant. And yeah, so thank you so much for that. So we go further down this rabbit hole, and they say, okay, forget paper. Why are you just staying with paper? We do want home compostable still. We heard that you're working very closely with Notpla and you know those guys really well. Do you think we can design something with a seaweed, or you also know a lot of great guys at PHA? Can we do that? Or you also know, you in your life, you also worked with chitons. So if you look at those three, and you can add another one, not two, Sandeep, you will probably know more more substances. So they come back to you and they say, okay, Sandeep, we understand that you are saying that moisture is a huge issue. Now, can you structure one of these three or four or five biopolymers that are emerging today and provide us a structure that doesn't have to be surface coated later? Is there something that would, how would you tackle that one then?
I mean, just to give an example of PHA again. You can do some things with PHA. Has some good barrier properties, but again, it's not a great moisture barrier. So the way a lot of companies are dealing with that is actually still applying a thin layer of aluminum, basically like it's like a vapor deposited aluminum, which would give you the moisture barrier, but at the same time, it's not causing any impacts on the compostability. I mean, it's still aluminum is a metal, so it can actually break down and go into the soil without causing any issues. So that is one way that I would look at solving that issue, is actually combining maybe a layer of PHA with a very thin layer of deposited aluminum, or another kind of maybe a there's other types of silicas and things like that are companies that are looking at, where they're again surface depositing some of these materials, um, where you can create a sufficient barrier without impacting the recyclability or the compostability and so on. So that would be an approach. I mean, I would say could be combining maybe one or two biopolymers with a layer of alox or another type of inorganic coating that would give you the barrier requirements.
And you didn't touch the other two. So you're going to stay away from seaweed and chitin or something else? Are those totally not workable when it comes to a moisture kind of barrier? Or would you also deposit aluminum on them?
I think even with those, because anytime you talk about natural polymers like chitin, or I think some of those materials, there's also P based proteins that companies are looking at. A company called Zampla out of UK that's looking at that. I think the idea is that they have really good like oil and grease barrier and maybe oxygen barrier, but the moisture barrier is always a challenge when it comes with natural polymers. So you would still probably need some additional treatment to get to the right barrier level. Uh, that said, there are I think ways to, like with chitin, there's work going on to modify the chitin to improve the moisture barrier. So I can see some maybe in the future some possibility of that being an option.
Amazing. And part of the reason why I've asked you with so many kind of different directions and substrates is this, like, I see this huge kind of hunger in you to kind of explore different directions. And of course, again, having met you a few times and seen the work you do, and I want to point this out and appreciate, what you do, like in terms of building this whole web space of Ubuntu, being on the advisory board of Sustainable Packaging Coalition, being very involved with TAPI, the Technical Association of Pulp and Paper, uh, adjunct professor at Clemson and North Carolina. So, so all these things, like why I'm mentioning these is that I'm sure it kind of widens the horizon for you in terms of your understanding of the space. So when you
Yeah.
look at it from each of these kind of things, what is it that you find that is really, because it takes your time and effort and energy to be
Mhm.
involved in so many and expense. They're not all probably paying you. You probably and now you are also, I forgot this one, the whole recycling association that has tapped you in again. So
Mhm.
so why is it? Why is that hunger there, that I'm going to devote my time and energy and mind and all the experience I've gained to continue to keep coming with solutions? That's the first part. And then how does it help you become a deeper thinker in the space?
Yeah, so I think one of the reasons that I started Cooler Solutions was that myself and, of course, my wife also, who has been a big supporter in this, we are really passionate about making a positive impact to the environment, especially for the next generation. That's really what drives me every day is how do I find the right solutions to address some of these pressing issues. And I know that that's kind of what your passion is as well. I know that you're being driven by that as well. So how do we make this a better world for the coming generations? And packaging being kind of the area where I've been really focused heavily on, that's where I would like to kind of continue to devote my efforts. So the way I look at it is being involved in a lot of these initiatives and efforts really keeps me abreast of what are the things that are coming, what are evolving, and how they might have an impact in changing the way we look at packaging materials and how can they better help address some of the issues. So, for instance, the seaweed based materials, I'm really bullish about that because I see seaweed as a I think it's something that's around the world. I mean, it's being we've kind of had it around, but we have not harvested it or we have not actually made use of it to a very large extent. And I see that as a great potential source for not just packaging materials, but other types of nutraceuticals and everything that we use. So I think one of the things that keeps me motivated about this is how do I take some of this information and also the knowledge that I've gained and apply it towards packaging to make it more eco-friendly, more sustainable, and in the end, reduce the impact on the environment. The other thing I think you mentioned about Clemson and North Carolina State is I'm also extremely passionate about sharing what I've learned over the years in terms of courses and training and teaching. And that's in fact over the last couple of years, I've been really stepping up my activities in that area because I'm finding there's maybe not a clear understanding of what makes materials sustainable, how they can be processed at the end of their life, how they can be recycled, and so on. So I've been doing a lot of teaching to large companies, brand owners, and so on about on these areas. And again, that keeps me really involved in this whole field of sustainable packaging and how I can share my knowledge and kind of that can be taken on by other people and applied to the industry.
Yeah, it's amazing to watch you flow because I remember even last year you were literally like, "Are you at Rethinking Materials? I want to come in." Can you, like, it was so much fun to, have you there and, like interact and see the amount of, and just watch you take it all in. You're always kind of observing and listening and questioning and trying to understand more and more and more. So based on that, and all good things have to come to an end, and I'm taking it towards closure. I know you have a limit on your time too. So, what is keeping you most excited? And this could be, I'm not even going to limit you to a substrate or a challenge or a company. If you look at the whole space in the next 3 to 5 years, what what gives you hope? What gives you true hope that this is going to change, really change some part of the world?
So I think what gives me hope is that there is a lot more awareness now about some of the challenges, and it's also reflected in terms of the regulations that are coming in. Right, I mean, different parts of the world are finally starting to put together regulations and legislations to try to meet some of those challenges, and also the fact that companies are realizing that sustainability, I mean, doesn't mean that you have to sacrifice on profits or the bottom line. So I think the way I see it is that sustainability can definitely be combined with a real impact to the bottom line. And so that's kind of the message that I'm actually telling people is you can actually be the way I look at it is doing well economically while doing good for the environment. So I think those two have to go hand in hand, and you don't have to do one exclusive of the other. So I think that's what really makes me hopeful is that companies are realizing that they can kind of do both things, not just one or the other. So I definitely see, I think, more focus on some of these, whether it's materials or approaches or even supply chains, right? I mean, you can make supply chains more efficient and more effective. Uh, so I think that's really keeping me positive and excited despite all the other things that are going on around in the world. I think I'm still very hopeful about the future for sustainable packaging.
Yeah, that's so good to hear, and I'm glad you mentioned the things that are going around in this world because I was thinking drill, baby, drill while you were speaking, and the calamity that is going to cause. But thank you so much for that idea, and of course, I have to ask you in the end, what does good garbage mean to you?
So I think this is a great forum to. You're doing a great. I think it's a great initiative that you've taken on to share stories and I think the positive things that are going on in the field of sustainability and sustainable packaging. Like I said, one of the reasons I got into this field was I felt that I could make a difference, and I think you have the same passion and the drive. And I think through this forum, you're able to bring some of these to a wider audience. And I've seen some of the past podcasts that you've done with a variety of companies, whether it's Notpla or some of the other leaders in this field. And I think so. I think that you're really creating a broader awareness, and I think you're doing a great job in terms of sharing this optimism for the future. So I thank you for doing that.
So this is the first time somebody's appreciated the podcast instead of good garbage being, okay, what does good garbage mean? So this is a brand new answer. So thank you, Sandeep. I expect no less from you. But thank you again, Sandeep, for being my friend, for always being available, each time. In fact, you ping me more than I probably ping you. Let's catch up and what is happening. So it's always such a joy to be in your space and to understand all that you're doing and collaborate with you and work with you. And of course, watch you kind of devoting time and energy in so many different directions to help find solutions, because we can crib all we want, but ultimately the key is what are we going to do about it. And it's just great, you're such an inspiration to see somebody who is constantly trying to find solutions. So I look forward to more and more and more collaboration with you. Thank you so much. Thank you for your time, for being on the podcast.
No, absolutely, and I would say the same thing. I mean, I talk to people in the industry all the time, and when I mention your name, Ved, I mean they automatically so we know him well, and I think you've built such a strong reputation and such a strong kind of a network within the industry. I mean, I commend you for that. Yeah.
Thank you, sir.